Hello and welcome to what is the fourth episode of Racing with UoNRT. Today, our guest is Fred Daly. He is not only the lead of the electrical team, of the racing team, but he is also, I'm not sure if I'm right, but one of our subscribers.
Yes,
That is very cool to see. How did you find our last three episodes?
I thought they were good. Yeah, informative.
That is the first positive response I've had to the podcast ever. That is actually, to be fair, one of the only responses I've got. So, obviously, you've heard many three people speak in that chair that you're sitting in. How do you feel in that chair?
I feel honoured to be here.
Honored, honored. Wow, did you hear that? Obviously, you are the lead of the electrical team. Explain your role to someone who isn't as mechanically minded as yourself.
So we have weekly meetings with the whole electrical team.
Yeah.
So there's about 20 of us, and every single person has a different role. So quite a lot of what we do is designing PCBs for various different tasks. So the car overall has, I don't know, maybe about 10 PCBs.
I'm just going to stop you right there. What is a PCB?
PCB's printed circuit board. So just one of
Ah,
those green rectangles covered in
like
little
motherboard.
bits. Yeah, exactly.
Okay, yeah, fair
Yeah.
enough. Yeah.
So there's different PCBs on the car and they all serve different purposes.
Hmm.
So, for example, in the accumulator, which is inside the big battery box, there's quite a few PCBs that are monitoring the cells, making sure it's all safe.
Yeah.
Then we have a PCB that's the ECU, so that's the brain of the car. That's
Yeah.
got its own PCB. And every year we normally have little updates we want to make to those.
Yeah.
So, for example, for this year, there's quite a few changes we're making, but a good example is the T cell, which is basically a light that's on top of the car to show whether the car's safe or not.
Uh-huh.
Formula One have a quite a similar thing. So theirs is purple and green. I think it's purple if the car's potentially unsafe to touch.
Uh-huh.
Ours is similar, so it's red if the car's turned on, so like it could move, just stay away from it.
Yeah.
Otherwise, it's green. And the problem that we've got is that the rules say it has to be visible in bright daylight, which isn't too hard to do. Just put some bright lights on it.
Yeah.
But then when we're in the workshop, it's blinding us because it's way dimmer in there and your eyes haven't adjusted.
Ah, right.
So a change we're making for this year, which is quite cool, is the T cell can adjust in brightness, a bit like your phone screen.
Yeah.
So when we take the car inside, the T cell will automatically dim. Uh, and that's an
Ah.
example of some of the changes. I think most of the changes for this year are sort of more cool things like that because we've got the car working, we can get through scrutineering, which is the tricky part.
Yeah.
So now the only parts that actually affect the performance are basically from the electrical side, the battery, which we're making a new one for this year,
Yeah.
the inverters, which we're getting new ones next year, and the
Mm.
motors, which we're getting new ones this year.
Yeah.
Everything else, like the ECU, that light on top of the car, the dashboard, they don't affect performance, they're just for convenience.
Yeah.
So we can make tweaks to those, and we don't really have to worry about slowing the car down or anything like that. So yeah, it's like the dashboard as well. We're making a completely new dashboard this year that should look quite cool and things.
So what's different to the
So
dashboard this year compared to last year?
this year we're moving to what we're calling the dumb dash, but
Ah.
it's better than last year, trust me. So last year's dash was basically it was a 3D printed box and it had a Raspberry Pi in it, which is like a mini computer.
Yeah.
But anyone with a computer will know when you turn it on, it takes quite a while for it to start up.
Yeah.
And that was the problem we had last year. So every time we turned the car off, which is quite often, because a lot of the time you have to turn it off and back on to fix things.
Yeah.
Um, so then when you turn it on, you'd have to wait 30 seconds for the dashboard to turn on before you could drive the car or like even see if the car worked properly.
Yeah.
Um, and that's because it had this Raspberry Pi in it, which is like a little computer. And we needed the Raspberry Pi for our telemetry system. But now one of our sponsors, Eigen, has provided us with a telemetry system. So we no longer need the Raspberry Pi. So now we can swap that for a microcontroller, which is like a really dumb computer that just turns on instantly. It's a bit like a calculator. If you imagine you turn them on, it's just on immediately because
Yeah.
it doesn't have like an operating system or anything like that.
Yeah.
So it's just like that. And basically, imagine like an RGB LED strip on the front of the car, like in front of the driver. And every single little LED on it, we can change the color. And that's basically all we need because right now the dashboard tells you, like, it tells you your speed, it tells you gearbox temperature, motor temperature, loads of stuff like that, which the driver doesn't really need to know.
Yeah.
All the driver really needs to know is for the endurance, how much battery they've got left. Because
Yeah.
then if it's running a bit too low compared to what it should be, they can drive a bit slower, things like that. But like for example, the acceleration event, all the driver does is puts their foot down. They don't need to see anything.
Yeah.
So basically, this new dash is just a strip of LEDs, and as the battery runs out, the LEDs will slowly change from green to red, a bit like a progress bar on a
Oh yeah, yeah,
computer.
yeah.
And it's just as simple as that.
What else is new to this year's car, the car you'll be taking in July?
Um, as I say, every PCB has had changes. Probably from the mechanical side, it seems like all there is to electrical is PCBs, but that's because most of the other stuff is sort of changes to components on the PCBs that people won't see, or we do quite a lot of software stuff, which again, people don't really see. Other PCB changes, we've got a new PCB, so we're adding something called the error code display. So on the side of the car, there's something called the TSMP panel, and basically that's just all the controls to turn the car on, turn the car off. It's not accessible to the driver. It's designed so that someone else can go up to it and turn the car on and things.
Yeah.
There's also buttons to, so for example, the car's got a big battery and a little battery, and sometimes the little battery will run out. So there's a button that then turns on a charger that charges the little battery from the big battery. And there's a few things like that. It's also got a big fuse box with all the different fuses. So basically, it's just this panel on the side of the car with everything we need to access. And now what we've added to that this year is this error code display. So because one other useful thing that the old Raspberry Pi Dash used to do is if there was something wrong with the car, unless there was something wrong with the dashboard, we could have a look at the dash and it would tell us what was wrong.
Mm.
So it would have, because it was just a screen, we could put on whatever we wanted. So we'd put on a number and then we could look up that number in the code in some documentation we've made. And let's say it said 16, we could look it up and see, oh, 16 means one of the cells is too low voltage or something like that.
Yeah.
But now that we've got the dumb dash, that's got no display, so we'd have no way of getting these error codes. So now basically what we've done is added a 2-digit 7-segment display to the side of the car, and that will show a number just like the dashboard used to. And then we can look up that number and find out what's wrong with the car. It's very similar to if anyone's got a fancy motherboard on their computer. That's what this was inspired by. So they'll have 2 7-segment digits, and that'll show the boot code. So if you turn your computer on, a sort of fancy gaming computer, if you turn it on and it doesn't boot, then it'll give you 2 numbers, and you can look that up in the manual, and it'll tell you what's wrong.
Ah, that is quite clever. It's quite an innovative solution.
Yeah, there's 1 or 2 other teams. So the Dumb Dash we've sort of copied from 1 or 2 other teams we've seen, but ours is definitely a lot nicer. But we haven't seen anyone else with an error code display. So yeah, we're definitely innovating on that side.
That is very, very interesting to hear. So you have talked about the new engine, well, not engine, battery that you are making. I think Saroja also touched on it in our first interview. Obviously, it's 25% lighter and it's got more energy density in it. Is that the right term? Energy density?
So it's lighter weight and it's got more energy. So the energy density is how much energy you've got for the weight. So
Yeah.
because we've got more energy and less weight, it's a lot higher energy density.
So, how involved are you with that progress?
Personally, for the battery, I'm not hugely involved because it was designed before I got here, basically.
Yeah.
Because the intention was to build this new battery last year, but because of the chip shortage, we couldn't get BMS chips. So that's battery management system.
Ah.
They're basically the chips that have a look at all of the cells, and they're constantly monitoring whether the voltages are too low or too high. They're checking the temperatures. And basically, because we're using lithium cells, there's 140 cells in series, and all of them have to have the same voltage across them to make sure it's safe.
Mm.
So if a voltage gets too high, the BMS chip can detect that and reduce the voltage by discharging the cell slightly. So those are crucial, and we couldn't get hold of those last year, but we found different ones for this year, and we've modified the circuit boards. So that's how we're managing to start to make progress with it this year.
Interesting. So how far has it come? Is it ready to be put into the car yet, or are you still?
It's not ready. We've had quite a few delays just due to manufacturers and suppliers. We've managed to find chips, but there's still a lot of delays in the pipeline, mostly just sort of hangover from COVID, basically.
Mm. Yeah. I mean, as long as the battery comes by July.
Yeah, we've already got quite a lot of it, to be honest. So we even last year we had boxes full of cells. So overall the battery has almost 1,000 cells,
Hmm.
and that 18650, which is sort of like big double A's, they're vape batteries basically.
Right.
Um, so we've had those for quite a while. We've got these big pieces of plastic, which I say big pieces of plastic, but they're a special material called PEEK, which is basically just really expensive plastic because it's got very good properties. I'm not mechanical, so I don't know much more than that, but I know it's very expensive, and that the plastic's basically going to hold all of the cells together so that they don't move around. That's recently been purchased and machined and everything. So that's a good step forward. Then I think the entire enclosure is on its way, which then we can actually start work on putting it all together because that's the thing we're waiting for at the moment. We've also got hold of this micro TIG welder, which is what we can use to attach the cells to the bus bars that are going to join them all together. And so right now we're just sort of figuring out how to use that because no one on the team's actually ever used one before, but they're very fancy. It's better to use than a spot welder, which is what's typically used. So that'll join all the cells together. Then these fancy plastic bits we've had machined will hold them together so that they can't move around. And then they'll all go in the enclosure, which is on its way. So it's looking quite promising for this season that it's all going to be good and tested. The testing takes quite a long time, but the design of this accumulator is a lot better than the last one. So the last one took a full year just to test it and fix all of the bugs. But this one, I think there's not going to be many bugs.
That's promising. And another promising project that Sarojit touched on was torque vectoring.
Yes.
Why don't you just start us off with torque vectoring? Just give us a brief explanation of what it actually is.
So torque vectoring is basically if you imagine you're in a car, when you're driving straight, all four wheels are spinning at the same speed, hopefully. But then when you turn to go around a corner, let's say you're turning left, the wheels on the right are going to have to go further than the wheels on the left because you're going around the corner.
Yeah,
So that means they're spinning faster. So the idea is that basically in a normal petrol car, you've got a differential and that allows the wheels to spin at different speeds. But we're not making them spin at different speeds. That's the road's basically just turning them at whatever speed they need to go at.
yeah,
The idea with torque vectoring is that because we've got a motor on each wheel, we can actually control this difference in speed. So basically what you do is you drive the outside wheel slightly faster, or you put more power on the outside wheel and you almost brake the inside wheel. And then with that, you can counteract the natural force that wants to pull the car away from the apex and basically sort of understeer or oversteer. And with torque vectoring, you can basically fine tune it. So if the driver wants a bit more understeer or a bit more oversteer, you can just tune between them. You'll never have a car that doesn't understeer or oversteer. It'll always lose grip at some point.
yeah,
And generally, you want it to understeer because that's a lot easier to deal with from the
yeah,
driver's point of view.
yeah. So essentially, what torque vectoring, from what I've understood, is that it basically allows both the wheels on the outside of the apex and the wheels closer to the apex to move around the apex at the same time. So the time it takes for the outside wheel and the inside wheel to exit the apex, and so between entry and exit is the same.
Yeah, so that'll always be the case with a car, just because all four wheels are attached to the car, so they're always gonna sort of start and finish the corner at the same time. But basically, with a normal car, we have no control over the difference in speed, and that difference in speed is partially what causes the car to understeer.
Yeah.
But with torque vectoring, we can essentially suck the car to the apex because if it starts to understeer, we can just sort of brake the inside wheel and put more power on the outside wheel. McLaren had something in, I think, the late 90s on their F1 car called brake steer, which was basically this, but for a combustion engine. So they had a third pedal in their F1 car, which was another brake pedal, but it was connected to the steering wheel, so it only braked the wheel that was on the inside of the corner. So this was when they had Mika Hakkinen and David Coulthard,
Yeah.
and Mika could take advantage of this a lot better than David could. But basically, the idea was that when they came into a corner, they could press this brake pedal, and then it would brake the inside wheel, and then just because of the differential action, you'd get a lot more torque on the outside wheel. And basically, it did exactly what this did. Um, but it's not very efficient doing it that way because then you're braking the inside wheel, and quite a lot of the power coming out of the engine is then just getting wasted as heat in the brake disc.
Yeah.
Whereas with torque vectoring like this, if we're braking the inside wheel, we can actually get energy back from that inside wheel and put it on the outside wheel, which is way more efficient.
So I'm assuming that's done via the generators that are inside the motor.
Yeah, so motors and generators are basically just the same thing. It's just if you grab a motor and spin it, it's a generator.
Ah, right. Well, I think that just explains my lack of mechanical knowledge. So another aspect about the engine that I've kind of missed was the new motors and the new gearbox. I said engine, but I mean powertrain. So how different are those two components compared to last year?
So the new motors they're very different. So they're the same peak power as last year, which is about 36 kilowatts.
Yeah,
So that equates to about a bit over 25 horsepower, which doesn't sound like a lot. Next year we'll have four of them on the car. So that's 100 horsepower on a car that weighs probably less than the 300 kilograms. This year's car will probably have about 60 horsepower. So we've just got two motors on the rear.
yeah,
But in terms of the difference from last year, the motors spin faster, which doesn't mean the wheels will go faster because we've got higher ratio gearbox.
hmm
But they also develop more torque. And when you combine that with the higher ratio gearbox, that means the wheel torque that we're going to have is way higher.
yeah,
And the wheel torque corresponds directly to the acceleration of the car, basically. So
yeah.
if you've got double the wheel torque, that's double the force pushing the car forwards, which means you'll reach 60 in half the time.
So that is particularly helpful for the acceleration test.
Yes, yeah. I think for the acceleration, it makes the biggest difference. But even for the sprint, we get the benefit of between every corner when we put our foot down, the car's going to go a bit faster.
Yeah,
And also for the efficiency, these new motors are quite a bit more efficient than the last ones. And the last ones were already sort of well over 90% efficient, which when you compare that to a combustion engine, the best combustion engines in the world are in F1. They're 50% efficient. A normal road car might be 30%, 25% efficient. And electric motors, you can get over 98% efficiency.
so that is a big, massive jump. I think we can see why electric motors are in, so much demand.
Yes, yeah, that's why EVs, on the motor side, when you compare a motor to an engine, there's absolutely no competition. Motors just beat them in every way. They're way smaller, way more powerful. It's the battery versus fuel tank debate that's a bit more of a problem from the sort of comparing electric cars to petrol cars.
And I
But
think that's mainly in like the form of safety.
it's mainly it's in energy density is the main problem. So like for example, in my car, I've got a 50-liter fuel tank. So if you fill that with petrol, it's probably going to be about 50 kilos,
Yeah,
and that'll drive me 500 miles.
yeah,
But a 50-kilo battery would drive the car maybe 30 miles, 40 miles. So it's less than a tenth of the range
yeah,
if you put a battery the same size as a fuel tank. Whereas a motor, if you compare a motor to an engine, the engine in my car might weigh 250 kilos or something,
yeah,
and that makes 100 horsepower.
yeah,
You could put in a 100 horsepower motor, and that would probably weigh maybe like 30, 40 kilos, something
hmm
like that for a good one. So a motor versus an engine, it's smaller, lighter, more powerful, and you don't need any gears because it's a bit like an engine that can go from 0 to 20,000 RPM.
yeah.
Whereas an engine, you can't go below maybe 1,000 and you can't go above maybe 6,000.
Yeah,
So that's why you need gears.
I think that's pretty much it. And then in terms of the gearbox, I think the main difference is that it's just a higher range. Am I saying it right?
Yeah, so the gearbox, so we don't, when I say gearbox, people might be thinking of like a gearbox in a car with multiple different gear ratios that you can change between. This is just fixed. So
Comparatively, what is it like when you compare it to, let's say, a
yeah,
manual
so
gearbox?
it's a bit like if you have a manual gearbox in your car, it's a bit like leaving it in first gear all the time. Because our motor can spin to 20,000 RPM, the new ones, we can hit probably 70, 80 miles an hour just
Yeah,
leaving it in that one gear. So basically, we want the lowest gear possible to get as much wheel torque as possible. And we don't really care that much about top speed because The acceleration is only, I think, 80 meters. So by the time you reach that distance, the car's not really going to be going that fast, even with the massive acceleration that the Formula Student cars have. And for the sprint and the endurance, you're going around a very twisty track, so you never reach a very high top speed. So yeah, the main difference of this gearbox versus the last one is it's quite a bit smaller and lighter. The mechanical team have done a good job at reducing the amount of material in it.
Hmm.
But yeah, the ratio is the main difference. So they match up with the new motors very well. So the new motors spin faster. So we're making use of that by using a, a shorter gear ratio, which will mean the motor has to spin faster for the car to drive at the same speed as the previous gearboxes.
Interesting, interesting. So now what I've done is I've introduced a new segment. It's completely different to the one we did with Chris. This one's called Ask by ChatGPT or ChatGPT Asks.
Mm.
I don't know which one. And we're basically gonna ask ChatGPT to ask Fred a few questions. I think I'll start off with the first one. What inspired you to take up electrical engineering? And in addition to that, why did you decide to be part of the racing team?
The electrical engineering part, I have no idea where the interest has come from, really. I think fundamentally it probably boils down to like the fact that electricity can do so much and is so influential in our world,
Mm,
but you can't see it and it's just invisible.
yeah.
Like it can kill someone, just leave no evidence. I just think the power of it's amazing. And what was the other part?
Why did you decide to be part of the racing team?
I'd heard of Formula Student before I came to university, and I didn't know Nottingham had a race team, and particularly an electric one. That's a lot more interesting for me.
Mm,
Um, until I'd applied, and then I found out about it. And the first day I got my university email, I emailed the team and said, "Can I join?" And I was told to wait, so I had to wait for the proper application process. But yeah, it's just my two favorite things. I really like cars and motorsport, and I really like electrical stuff.
yeah,
And this is an electric race car that we get to design and build as students.
yeah,
And also, I've done a lot of electronics projects before at home before I came to uni, but that was always independent stuff. And I
yeah.
thought this would be the perfect opportunity to learn to work as a group.
So it's basically the best of both worlds for you.
Yeah, it's a lot better than the course. This is just perfect.
Oh, that's amazing. The second question that ChatGPT wants to ask you is so obviously you've been a part of the team for 2 years. The first year was as a member of the electrical team.
Mm.
Obviously now you have been promoted to lead the entire team. Over the 2 years, what did you find most challenging?
Probably the start of this year, having to make the step up from just a member where you can just hide at the back of a meeting, get away with not doing much. Now stood at the front, talking in front of people. It was very daunting at the start because I'm not a particularly outgoing person in terms of socializing or like just talking to big groups. So the first meeting where I was stood at the front, I was shaking and sweating and yeah. But it's been a few months now, and I'm really enjoying the meetings now. I sort of take a quick register, and then I get to walk around to every person, find out how they're doing, and everyone on the team's great this year. Really, I can go around and everybody's done something from the last week,
Yeah.
designing PCBs. I'm constantly getting asked questions in between meetings, which is good. It shows people are eager to work. I even got questions from more than one person on Christmas Day this year
Ooh.
asking, "Fred, what footprint should I use for this component on the PCB?" and things like that. I'm so impressed with this year's cohort.
So you've got a very dedicated team.
Yeah, yeah, it's brilliant. Hopefully, most of them are first and second years that should be around for a few years as well. Because from last year, there's only me and one other person that stayed on the team because we had so many leaving and graduating. But I think this year's the start of something very good for the electrical team.
And I think considering the changes and the improvements that are being made on the electrical side, it's going to be quite interesting for them to be a part of it as well.
Yeah, I can't wait to see what the car looks like when I graduate in, I think, 3 or 4 years' time. Because, like, for this year, we're already doing cool things like the dimming T-cell light and the dumb dash.
Hmm.
So just imagining another sort of 3 or 4 years of developing cool stuff like that. Yeah, the car's going to be. I don't think any other teams in this country are going to be able to compete with us.
Oh, hello. And ChatGPT also wants to ask you. I think this is a really, really important question. Obviously, you are very skilled in being an electrical engineer.
Mm.
I mean, you've got your own setup at home, a full-on setup as well. What skills do you think are important when you want to get into electrical engineering, and when, especially for your team, what skills do you think are most important for them?
I would say just do things. So for people that are wanting to join the team or thinking about studying electrical engineering at uni or anything like that, just get your hands dirty and get started. You can. It might seem a bit daunting at first, but you can buy sort of a cheap soldering iron, an Arduino, something like that from Amazon, and you can just get started making a circuit. If you can't think of a project, just do what we've done and ask ChatGPT and play around. And it's got some great project ideas. And yeah, just sort of get your hands dirty. Really, anyone that applies that's done any projects in the past, especially if a first year's done something before uni, and they say like, "Oh, I made a little robotic car or something," they're straight on the team because that's what we're looking for is anyone with past experience. And it's the doing is much more important than the theory. If someone turns up and says, "Oh, I've read lots of books about electronics," but they've never actually built something, it's the building that's the main thing. And that's also it's not it's not necessary to be on the team because that's what you develop. That's a key skill you develop when you're on the team. Is to be honest, the electrical engineering course at university, there's quite a lot of theory, and you don't do a huge amount of hands-on building circuits, especially debugging a circuit is a really useful skill to have for after university. So if you build your circuit and it's not working, the course doesn't really teach you how to do that. But Formula Student, you learn so much more. And companies looking to employ people know that. If you want to apply to a Formula One team and you say, "Oh, I was on Formula Student, I did this, I know how to do this," then you're straight to the top of their list.
Yeah.
So there's multiple people on our team that they've got offers from Formula One teams, they've gone to work in Formula One teams. That's mostly because they're on the Formula Student team. You could get a first class degree, but if you're not on a Formula Student team or something comparable, the F1 teams aren't really that interested because they'll get thousands of applications from students that say, "I've got a first class degree, I've like done a final year project doing this or whatever," but if you haven't done something extracurricular, especially like something motorsport related, when they've got that many applications, they're just looking at the people that, "Oh, well, I could either have this person with a first class degree, but no practical experience, really,
Yeah.
or I could have this person who didn't do so well in their degree, but they've built an electric race car and they're coming to work for a company that builds a race car." So, like, who do you think they're going to pick?
I think the person who built the race car.
Yeah.
So I think the moral of the story is experience is valued more than a degree.
Yes, I think so. A degree is helpful. If you don't have a degree, they probably won't look at your application at all. But I think I can fairly confidently say you could have a worse degree and be on the Formula Student team, and you'd get more job offers than if you had a first class degree but you weren't on the Formula Student team. As long as you can prove to employers that you've actually done something, because there are quite a lot of people that hear that and they're quite tempted to join, but they don't want to do much.
Yeah.
But if you join and get stuck in, yeah, it's you're having to decide which jobs you want to turn down, which job offers you want to turn down.
Ooh. Being in that,
Especially, yeah,
to have to be in that position is a privilege and a half.
yeah, especially at the Formula Student event. There's people from F1 teams there looking around for good team members. They literally just give you a business card and say, "Give us a call."
That is impressive. Maybe I can give it a go. Just pop up and try and showcase myself to Toto Wolf, hopefully.
Yeah, I'm sure he'll be there.
And I think a final question. We'll have this last one. So obviously, you are invested both in motorsport as well as having an interest in the electrical side of it. So there is Formula E and there is F1. Will the popularity shift towards Formula E as electrical powertrains become more popular and therefore more relatable to a vast proportion of viewers? So do you think Formula One, at some point, despite its efforts to, because essentially Formula One and Formula E are two completely different series, mainly because of their powertrains. And despite Formula One trying to do everything they can to make their engines a lot more efficient, do you think at some point in the future viewership might shift to Formula E?
It's a very good question, and I can't predict the future completely, but I think F1 has just built up such a big reputation amongst sort of sports fans and things, especially at the moment. It's having a huge revival. I think if F1 can't go electric because Formula E actually have like an exclusivity agreement, I think for like 40 or 50 years, that
Ooh,
basically says there can't be any other big electric race series. So F1 can't go all electric. They're not allowed.
wow, okay.
So yeah, but I think even in 20 years' time when we're all driving electric cars, I think whatever F1 end up doing, I think it'll probably still be more popular just because realistically, Formula E, it doesn't have the same caliber of drivers and it just doesn't have the reputation. And I think also a lot of people, myself included, see Formula E as a little bit gimmicky. So you've got like the fan boost. I don't know if they've still got that, but sort of things like that. They're also the circuits, there's no proper tracks. They're all street circuits,
Yeah,
which is a bit weird. So you never get to see the cars going like properly flat out. I think that's mostly because if they went to a proper circuit, they'd drive so fast they'd just run out of battery too soon.
yeah,
Um, but Formula E is definitely interesting. I've seen a race in London, and it's very good to go and watch in person. I think it's better than F1 to go and see in person. It's much cheaper. The cars actually sort of like bang around and things. It's good fun to go and see. Um, compared to Formula One, where you're spending hundreds of pounds to just stand in a huge crowd of people and see the cars not very often.
yeah.
But yeah, in terms of overall popularity, I think unless Formula E have quite a big change in how they're doing things, I think Formula One's going to still stay at the top.
Interesting, interesting. Now that we're on the topic of Formula One, and now that the Bahrain Grand Prix has already happened,
It has.
who do you back to win the World Championship? Both of them.
For the championship, Max and Red Bull, I think it's hard to look past them.
Yeah, yeah. And I think especially after the new regulations, they have been quite dominant. And I'm assuming Red Bull are your favorite team.
Yes, but not because they're winning at the moment. I've liked them since I started following F1 quite a long time ago. That's mostly because I think they're the team that closest resemble my favourite team of the period, which would be Williams in the 90s, especially early 90s.
Hmm.
So in 92 and 93, they made the FW14B and 15C, which even compared to modern cars were miles ahead in terms of like everyone regards them as the most technologically advanced F1 cars ever.
Yeah,
Before in 94 they had what was called the gizmo ban. So these cars had traction control, they had what's called active suspension. So the car could basically, instead of springs on the four wheels, on the four corners, the car could just actively change its ride height. So there's a few cool videos on the internet of the car just like moving up and down like a creature.
all right.
It's crazy. So they could adjust. They had like active damping, so a bit like in fancy road cars, you can go for like a soft ride or a hard sporty ride. This is where that technology came from. It's from these early Williams. They even did a test with a CVT, so that's basically a gearbox with infinite gears. It has a belt, and they were just testing so much it was insane. And then F1 were just sort of thinking like, you at this point you barely need a driver, so they banned all that stuff. But Williams has sort of gone, especially since the late 90s, Williams has just gone downhill a bit, and they're not the engineering focused team they used to be.
Yeah,
Whereas Red Bull, I think at the moment are the closest to 90s Williams,
yeah,
closest we're going to get. Because to me, it seems like you can tell from the fact that for a long time they've had way faster pit stops than anyone else.
Yes.
Consistent. I think they're just the best race team in terms of like organization and I think most of the hybrid era, I think they've had a better car than Mercedes. It's just the engine that's been slowing them down. They've got Newey, who's just miles ahead of anyone else
He's
technically.
he's a god for
Yeah,
aero. He's an absolute god.
100%. So yeah, I think that's my main reason for liking Red Bull. I know a lot of people take issue with Horner and Max, but I'm not really into F1 for the personalities. I'm just into it for the engineering, and it's always Red Bull that are doing the most innovating.
That's interesting because I'd have thought in terms of innovation, Mercedes were up there, especially with their new DAS system. I think that was the one where you just push the steering wheel in and out so that you adjust the angle of the front two wheels. And I think that was like for me, having started watching Formula One since like 2014, that was incredibly innovative for me to look at. And especially considering how well Mercedes were able to adapt to the hybrid era in terms of their engine. I mean, to be fair, Red Bull, they, in terms of engineering, in terms of the aero, in terms of the everything else apart from the engine, they have been miles ahead of Mercedes, and I think especially since the introduction of Honda as the engine supplier after quite a few tumultuous years with Renault, they have kind of come on par. I think it was since the start, it's since the introduction of the Honda engine, they have basically been on par with the Mercedes. And I think that backs a point about it being the problem with engines. And especially considering now that Red Bull are making their own engines, which is something they have not done before. I think that's quite interesting to look at.
Yeah, I think Red Bull powertrains is definitely one to watch, and like you can see, sort of in 2009, Brawn won, but Red Bull were catching up with them and had by far the fastest car at the end of that season. Then 10, 11, 12, 13, Red Bull dominated.
Hmm.
And then the hybrid era, I think they still had the best chassis and the best aero. It
Hmm.
was just the Renault power unit that let them down. So we should sort of be grateful that Renault did that, because otherwise Red
Oh,
Bull would have just won sort
yeah.
of 2010. They'd still be winning now. It would be crazy.
Yeah.
So yeah, but as you say, they swapped for Honda, and once Honda got the hang of what they were doing, they caught up to Merck. And like a lot of people say for 21, it was the floor changes that pulled Merck back. I think it was partly that, but I think more of what helped Red Bull was that because Honda were pulling out, they brought forward their upgrades for the 22 season to 21,
Hmm.
the engine upgrades. So that was a huge engine leap, and that was by far the best engine on the grid in
Yeah.
21. And I think that's what got Red Bull the championship quite a lot more than the floor changes slightly hindering Mercedes.
Yeah. Yeah. I definitely agree with that. Considering now it seems to be like Red Bull are going to be dominating for the next few years as well. Hopefully, the Ford engine coming in at 2026 doesn't do another Renault. Um, I mean, I hope it does because I
Yeah,
think people are getting quite tired of Max being what 40 seconds ahead of Fernando Alonso.
yeah, it's a tricky one, isn't it? You sort of Red Bull will want the Red Bull powertrains and Ford sort of collaboration to go well, but from a competitive standpoint, we don't really want that. I reckon by the end of these regulations, sort of probably 2025, I think it won't just be Red Bull dominating. Another team will have caught up. Might be for Ferrari, might be Mercedes, might be Aston Martin. Probably one of those three. But I think teams will catch up with Red Bull, especially with the aerodynamic testing restrictions and the budget cap. I think they're going to do quite a good job at balancing everything out. It just will take a while.
Yeah, I definitely agree with that. Talking about the new regulations, obviously there have been changes in the engines. There have been new regulations passed about the engines. Can you talk us through it? Because I've tried to kind of wrap my head around it, but because of my complete lack of, do I say ability? I don't know, complete lack of what's the word to understand anything engineering related. I just have not been able to. So, do you want to give it a go?
Yeah, so last season, for the 2022 season, there was a big change in regulations that most people were saying sort of definitely the biggest change in regulations since the flat floor regulations in 1989, I believe. And that was basically a big shift in how the aero's done back to ground effect aero. So now a lot of the downforce comes from underneath the car,
Mm-hmm.
whereas in previous years, basically anything from sort of 89 up to 20 would have been 2021. The rules specified the cars had to have a flat floor, so there wasn't a huge amount of downforce coming from the underside of the car, and that's just because in the 80s the ground effect cars were very dangerous, and sort of they just banned it for safety reasons.
Yeah.
But now the understanding of that's so much better, they can reintroduce it in a much safer way. And you could see it still wasn't perfectly safe with the porpoising we had last year,
Yes. Yeah.
but all the teams are getting their heads around that now, and overall ground effect's a lot better because it's a lot less susceptible to the dirty air problem. So you can drive right behind another car, and the car's still sort of giving out dirty air, but the air going under the underfloor doesn't have to be as clean as it needs to be for air on overbody surfaces like the rear wing or the front wing.
Yeah.
So, yeah, for last year, the engines didn't actually change at all. It was all aero changes. And for this year, they've just made a few tweaks to the aero, mostly to try and mitigate the porpoising a bit. But the changes to the regs that have been announced recently are for 2026,
Uh,
which sounds quite a way away. But the teams are already, even last year, the teams are looking into the new engines and things. So 2026 is exciting because it's new cars. So it's new aero. Basically, everything's changing. It's not just aero, new engines. And from the aero side, they haven't really said that much yet. It's going to be a continuation of what they're going for this year and last year, which is what Ross Brawn was calling raceability. So just making sure that the cars aren't affected by being close to other cars too much. But in terms of the engine side, they've announced quite a lot now, and the main reason they're giving out so much information at the moment is because there's various teams like Porsche and Audi and Cadillac have teamed with Andretti that are looking at joining for 2026, and they need to know all the information about the engine that they'd have to build. So, for example, they've got rid of the MGU-H, which is part of the hybrid system, which is one of the key things that's allowing these engines to be almost twice as efficient as the engine in a normal road car. But the reason they got rid of that is because they're really complicated and expensive, and the new teams would have they'd be on the back foot compared to the existing teams, and they'd have to develop that from scratch, which would cost millions of pounds. So they're dropping that. They're increasing the electric output of the hybrid system, so now it's going to be 50% combustion and 50% electric. That's to try and still keep it somewhat relevant to road cars. So the hybrid system on the new 2026 cars is going to be a lot more relatable to road cars because there's no road cars apart from the AMG Project One
Yeah.
that have an MGU-H, and the reason that car's been delayed by multiple years now is because quite a lot due to the MGU-H and just how complex it is. It's not designed to go on a road car, so Mercedes trying to put it in one is I can see why they're having trouble. But yeah, so now the hybrid system is going to be a lot simpler. It's basically an engine and a motor,
Yeah.
and the motor just sort of complements the engine. So like when you're changing gear, you might have a slight drop in torque. The motor can compensate for that and just put in a blip of power. Also, like if you're just driving around slow, you can just run off the electric motor. That's what a conventional hybrid road car would do. And yeah, overall, it just means the new powertrains are going to be quite a lot simpler than what there is at the moment, which should be a lot cheaper. And that's something they're going for, is with the cost cap era and everything like that. They want the engines to be simpler to encourage new teams to join.
That's very interesting. And I think 2026 will be quite an exciting era for Formula One because we haven't seen more than 10 teams competing in a single Formula season for more than, I want to say, 1 decade. I might be wrong. But still, it's quite an interesting prospect. I mean, especially for the newer viewers who haven't seen more than 10 teams compete. It just increases the level of competitiveness on an F1 grid, and especially seeing the big dogs like Audi, Porsche. Porsche might not be coming in, but Audi definitely has a project with Sauber at the moment, and Ford as well coming in, and Cadillac and Andretti. Andretti is obviously a big name in many motorsport series, so I think it's a very interesting prospect to look out for. So to end off the podcast, we'll follow a common tradition. What are your aspirations to at the end of the year? What do you hope of achieving by July, let's say?
So I think the main thing for this season that the team is aiming for is just to prove the reliability of the new motors, new gearboxes, and new battery.
Mm,
Because next year we're going four-wheel drive and the car's going to be very fast.
yeah.
For this year, we'll have the new motors. We'll have two of them, two of the ones that we'll have next year, four of.
Hmm.
We'll have the new battery that we're hopefully going to keep for a few seasons. So we just want to sort of prove that they're all working perfectly so that next year the integration of the new inverters, which is what controls the motors, will be nice and smooth. So yeah, I think the main goal, we're not expecting to win this season. We'll probably do pretty decently on the efficiency,
Mm,
which would be for the endurance event.
yeah.
But for the acceleration and the sprint, we're limited by the fact we've only got two motors, so we've got half the power of four motors. So we can't compete with quite a lot of the teams, especially the European teams that come over, because they've got four motors, four-wheel drive, they've got a lot more power than us.
Yeah.
But for the efficiency, we can probably do fairly decent with the powertrain we'll have this year. And as I say, it's mostly just proving all the new additions for next year.
Thank you for coming on, Fred. Thank you for taking your time. And well, I hope the team at least gets close to winning. Hopefully, it's a very successful year. As for the listeners, thank you for tuning in. I really do appreciate. If you have any comments, please do leave it. Fred was the only person who commented anything about this. And yeah, see you next episode.